Hello, friends, students, and enthusiasts. So I'm back with one more project in our project series. A very simple project for all grade of students. This is non-IoT project. Anybody can do it, but it is related to robotics. So name of the project is building a self-navigating autonomous robot with Arduino Nano. Right? Arduino Nano is a small board. So with that, we have built this project. Okay, let's go to the other part, that is, we'll see about the project. This guide will walk you through creating a simple yet effective autonomous robot. Please remember autonomous robot that can navigate its environment using basic sensors. Okay. So what are the sensors? Which sense the environment and accordingly behaves. The robot will avoid obstacle and follow light source if desired. That means we are using one sensor, which will be like for it can observe light also, or we can use it for other purposes also. So we will discuss that further. So components required, as you can see, very simple, very few components. Arduino Nano, that is there on the right hand side, is a small board from Arduino. Very cheap board. LN298N motor driver. This driver we need it. You can see on the bottom right hand corner, we need this driver. That is for driving the robotic motors. Let it be 2 or let it be 4 wheel. So 2 into DC motor or for with the wheels, that is, I have used a chassis that is with the 4 wheels. I have connected those with all two motor on each side in a series, and then have taken out a common connection. Caster wheel for balancing, if you want, you can use it for balancing purpose. Then I have used one ultrasonic sensor for distance measurement, that is for obstacle avoidance. I also use 3 IR sensors here. I will just tell you what is those sensors and why I have used it. Then 9-volt battery for rechargeable battery. I have used jumper van and breadboard. These are the components, simple components you need to have for this. So for the circuit diagram, since the diagram or the connection is very easy, I'm just giving you the pinouts. So from Arduino Nano pinout, D2 goes to ultrasonic eco pin, D3 goes to trigger pin, D4 goes to IR1, D5 goes to IR2, and D6 goes to IR3. Now what is IR1, IR2, and IR3? That I will just tell you in the coming slide. Okay. So 3 IR sensor I have used it here. Then next is D7, D8, D9, and D10. These are the motor connections. That means 2 to each. Motor A and motor B. IN1 and IN2 are used for motor A, and IN1 and IN2 is used other one, D9 and D10 is used for motor B. And D11 and 12 are enable motor A and B. This is for control. It's a speed control I have used. I have removed the jumpers from the driver, and I have used a separate pin or separate connection to D11 and D12. 5-volt power supply. Okay, it works on 5 volt that I have taken from the same board which has a 5-volt regulator also. Then common ground. Okay, now here you understand the navigation logic, that is how it is going to work. The normal operation, robot moves forward. That means when no obstacle or such thing, it will go forward, forward, and forward. When no obstacle or IR trigger detected, when something is detected in front of IR or obstacle trigger detected or ultrasonic, object which is distance will be less than 15 centimeter in front, right? Reverse the motor or the robot for 500 microseconds. After reviving, check IR sensor for direction. Okay, it will sense that IR, if you are getting any signals on the IR, then it will check for the direction. right? So IR1 is right turn. That is, if you put your hand in front of that, it will turn right. The motor will turn right. IR3 is turn left. Okay, right. And IR2 stop completely. That means if you want to stop the robot, you place this thing. If something comes in front of this, it will completely stopping the robot. No IR, that means though all the three IRs are not getting any signal, the random turn will be there. Okay. So these are the points you have to remember. Continuous monitoring, all sensors checked every 50 microsecond for responsive behavior. That means the timing in the codes. All right. So this is the very simple code. Will just go to our main lab. I will explain you about the codes and we will see the live demo also.
All right, so this sensor will be the line sensor. That means it will detect line and then only the motor will start. Okay, so I will just explain you the things and all what I have used. So this sensor is this type, this sensor, that means this one is for turning right. That means if it comes from any side, it will turn right naturally. And there is another sensor on this side. This sensor is for turning left. This is right, this one is right, and this one is left. Okay, and there is an ultrasonic sensor which will change the direction. This will stop and change the direction, this ultrasonic sensor. Okay, so two batteries I have used, motor driver, Arduino Nano. Okay, so connection I will be sharing with you. When line is sensed, then only it will start. When line is not sensed, that means the robot will not work. The robot will not work. This will obstacle detection. This is for left and this is for right. Okay, so I will just give you a small demo. Now it is sensing. Okay, so it's running. Okay, so it's suppose an obstacle is there, it will turn. It will turn right also, it will turn left also. Okay, so likewise it will be sensing around. Okay, so like I'm just showing it to you how it is sensing. Like now no sensing, it is continuously moving. Line, if line I lift it up, so it stops. Why? Because it's not sensing the light. Okay, so this is a stop sensor, you can say, and if it senses the light, then only it will start working. This is for changing the direction. Okay, so this is an autonomous robot which can change the directions.
Simple codes of your project, that is building a self-navigating autonomous robot with Arduino Nano. So we'll just discuss about the codes and all. So you have only one library here, that is a new ping H library that is used for speed control of the motor. It's a new library, you can download it. So in the pin definition, as we have seen that we have used a ultrasonic sensor. So 3 and 2 pins are for this. Then IR pins, 3 IR pins, 4, 5, 6. Okay, IR 1, 2, 3 stop because it's given here. Then you have motor pins, that is These 4 points are important for us, and ENA, ENB, that's 11 and 12 are there for that. Okay. Now, next is constant, that is about the timings and all, what distance and what coverage will be there. So here it is given the time, reverse time, motor speed, obstacle distance, and max distance. Motor speed, why we are taking, why? Because we have connecting ENA and ENB, that is ENB connections accordingly. That is for PWM pulses, which will be coming from the Arduino Nano. Okay. So then you have a void setup. In void setup, output and input pins are given. Initializing sensor pins, what are the pin modes we have to tell? Input, 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 that is IR, all the three inputs, right, center, left. Then the baud rate is 9600. And void setup will explain the complete this thing. Okay, that is when it should turn left and right and everything. All the details will be in this. Right, so we will be sharing this complete this thing. Simple codes, not very difficult, but a little lengthier. Right? Why? Because motor control functions you have to write down 1, 2, 3, 4, 5, and 5. Okay, 5 controls are 1, 2, 3, 4, 5 controls are there. These are the motor controls. So because you have to give the commands, so it how many combinations will be there, that we have given. Obstacle, this obstacle information is here, that it is given here. Then left, IR left and IR right. So when it should be turning left and when it should be turning right, at what particular condition. And delay time is last motor start, motor stop motor, and delay time will be 100. So simple code, I'll be sharing this code with you. And it's very simple, but little changes I have made in this. That is, instead of 2 sensor, I've used 3 sensor for this. And accordingly, you can add or you can change the pin numbers also.